Now we can discuss the subject of network analysis. Each and every basics will be discussed in this session. But this subject can also be called as a circuit analysis also. But what we are going to discuss in the network analysis, is it a synthesis part or analysis part we are going to study? First, you need to understand what is the difference between that synthesis and analysis. Suppose you are given here any network is given here. This is connected with input also given. Suppose input also given, network is given. Is asking in the question, find out the output parameters. Is asking to find the output parameters. What those output parameters are required? You may ask to find out the current through any element or voltage across any element. Otherwise, you may ask to find out the power. Any one of the parameter at the output level you may ask. In that case, we need to do the analysis part only. So to do the analysis, what is required? Input is a must, network is required. Then you can determine the output parameters by using the analysis only. That is analysis. In case, when you can say synthesis, in case input is given and output is given, and what network is required, how to design the network is nothing but the synthesis only. To get the required output for the given input, how to be designed a network or circuit here now is said to be what? Synthesis only here now. In the GATE exam, we can find the analysis part only now. Even in the competitive examinations, it is given a much importance of analysis only now. But only in the engineering services, synthesis part is included only here now. Yes, now we can start the subject here now. Yes, what we have to discuss initially, what is circuit, what is the network, difference is more important. Without knowing those two terms, we should not enter into the what now? Next level. So initially, I wish to explain what is circuit. The students may have a doubt sometimes, circuit and network are equal or not equal. How we can define the circuit, how to define the network is more important now. Any closed path formed by the number of electrical elements for the transfer of the current is called as a circuit only now. Exactly how we can define any closed path, formed by interconnection of electrical elements for current flow is known as circuit only. Like that we can define the circuit only now. Sir, I don't understand clearly. Still, I want the clarity, sir. Very good, we can give. I have drawn a diagram in this way. In this way, I connected here now. There is a source. The source I connected here now. This can have, this is the EMF we can call, electromagnetic motive force, resistance R1 and resistance R2, I connected here now. This here we are finding the closed path. A closed path is existing here now. By using the what now? Electrical elements only, R1, R2, not only resistor, even you want to have the inductor or capacitor, anyone we can connect here now. In this closed path, then it is going to flow. Why we are connecting? To allow the current to flow in the circuit only, we can say now. This is circuit only. Closed path is a must. If it is an open circuit, you think it's out. We can't say this is a circuit only now. That is very important now. Now, how we can define the network, we can see. How we can define network. Then you can understand the difference between these two only now. Network, how we can define. The network, if you want to define, means you can write like this only now. What way we can define here now? It may be or may not be a closed path only now. It may be or may not be. May not be a closed path. Closed path only now. Very simple way I define only, you can see. That means if the closed path is formed, means we said there is nothing but a circuit. But it may be or may not be a closed path if you got there is a network only now. For example, I have drawn like this. Same resistance I connected R1. Here I connected resistance of R2 and I connected some voltage. Sir, is it a network or circuit? I said it may be a closed path. Yes, we are having a closed path. Closed path, whenever you are having, this can also be called as a network. This can also be called as a network, or circuit also we can call. A circuit can also act as a network only here now. In case I have drawn the diagram in this way, there is a battery here, and I connected a resistance R1 here, and I connected one more resistance R2 here, and one more resistance I connected this side. But the side, just I connected the resistance R4, but I didn't connect. I stopped there only now. Yes, it may be or may not be a closed path. Here closed path is there, here closed path is there, here we don't have any closed path now. So it can also be called as a network only. This can also be called as a network only, we can say. Every circuit can act as a network, but every network cannot act as a circuit only. That's very, very important one now. Anyhow, the difference between the what now, circuit and network only. What I said, circuit, any closed path formed by what? Number of electrical elements. Why? To allow the current to flow. That is nothing but the circuit only. What is the network, sir? It is also what we can say. It is also a what now? It may be or may not be a closed path. It is formed by what? Number of electrical components only now. But what you can find now? It may be or may not be a closed path only now. I said only now. That is a network only. We said the now. And next a few more definitions are very important here now. The next definition I will go the now. What is the node? We are going to use in the network analysis. These are the words, node. How to define the node? Whenever we are applying the nodal analysis and mesh analysis, we are going to use node and all now. Anyhow, we can say node. Definition of the node is given as a point where, first I will give the definition, then after I will explain. A point where two or more elements connected, elements connected only is called as a what? No, node point only. A point where two or more elements are connected is called as a node only. What is the meaning of this? What is the meaning of this node? I will explain now. Suppose I connected one resistance like this, one more resistance I connected this side, one more resistance I connected here only now. A point where two or more elements connected only now. Which point is to be taken as a node? This point we are going to call it as a node only now. This point only we are going to call it as a node. That's why a point where two or more elements connected only now. Two or more. Two, here the three are connected only totally, you can say. That becomes a node only now. Understand? This becomes a node. I think students could understand. A point where two or more elements connected is known as a node only, we can say now. So whenever I said the node, immediately you will get the what? No, concept. What is the meaning of that node? You can understand clearly. Understand part. Next, a degree of node I want to give. Degree of node is also more important. Degree of node. Initially, I will define that, then after I will explain clearly now. You will get the clear concept only now. Number of elements. Number of elements. Number of elements connected to a node is called degree of node, we can call. Is called degree of node. Like that you can define. What I gave it here now? Number of elements connected to a node is called as a degree of node only. Suppose the diagram, same circuit I have taken here now, for the same what node network I have taken here now. In this network, this is the node we got. The node is connected to what? How many number of elements? You watch it now. How many number of elements are connected? First one, second one, third one. 3 elements are connected. If 3 elements are connected to the node, means we can say degree of node is nothing but the 3 only here. How many number of elements connected to a node is called as a degree of the node only, we can say. That's why directly we can write now. Here the degree, suppose the same network, what is the degree of the node? 3 only possible. Now one more point you have to understand. If the condition very important, if degree of node is equal to 2, you think it's so. Suppose you are getting the 2, degree of node is a 2. It is called as a simple node. That node is called as a simple node only. A name given to the what node is a simple node. When we can say it is a simple node? Whenever number of elements connected to that particular node is nothing but that 2, you think it's so. We are going to call it as a simple node only. In case, if degree of node is, degree of node you are getting the what not greater than 2 you are getting, for example. Greater than 2 you are getting. 3 or 4 or 5 or whatever number it may be. More required now. Greater than 2 whenever you are getting, that is called as a what now. That name given to that node is nothing but the principal node only, we can call. Principal node we can call now. That is called as a principal node only now. Like that we can define that now. If the degree of node is nothing but the 2, we are going to call it as a, we can call it as a, okay, thank you Nikhil. But if the degree of node is a 2, it is a simple node. If degree of node is a greater than 2, it is called as a principal node only, you can say. Like that what you can say, we can define this node only now. Understand my point now. I think the students got some idea regarding the node here now. And now we can enter into the next point. branch. What is the branch? It is very, very important. We are going to use mostly all these points. Branch. What is the meaning of the branch? You need to understand now. Understand now. But here the name it is given. It represents. It represents. It represents an element. An element that connects two nodes together. Two nodes together I can write now. This is nothing but branch. What is given here now? It represents an element that connects two nodes together only now. Two nodes together means what is the meaning here now? How many branches are there? How to find out a branch clearly you can understand now. For example, I have drawn one network in this way. I connected one network in this form. All these are resistors only I have taken here now. This is the source I connected here, for example. And in between these two, I connected with a resistance again. And I connected with one more resistance this side. I connected one more resistance this side only. After plotting this diagram, I am asking the question here now. How many number of the nodes are there? How many number of branches are there? I ask for example. How we can take? This is to be taken as a one node. This point is to be taken as a one node point only. This is connected to how many number of elements here? Source 1, one more resistance, one more resistance. Two or more elements are connected to the what now? Any point that is called as a node only here now. The first node we are going to have here now. Node 1 we can put otherwise here now. Node 1. This becomes a one more node. Second node I have taken for example. And also I can take this also one more node. Third node I can take now. This is the resistance, that resistance and this resistance connected only now. And next what node? Where to be taken one more node? The resistor is connected to this side, this is connected to this side. Totally it becomes a single node only here now. Don't take this is one more node, this is one more node, one more node. No, we don't have any elements here now. This can be taken as a one more node. This is the fourth node I can put here now. Totally how many number of nodes it is existing for a given circuit? If I ask directly, you can say 4 nodes are existing only. You can say now 1, 2, 3, 4 nodes are existing only now. How many number of the branches are nodes are how many here? We can write directly number of nodes are 4. It is existing only. How many number of the branches are existing in the given circuit? I ask for example. Branch means what I said. It represents an element that connects two nodes together. Between these two nodes, it is connected one resistance only here now, one branch. This is a one branch only. Between the two nodes, any one of the element is connected means this becomes a second branch we can call it now. Between the two nodes, it is connected one more here now. Between the two nodes, connected one more branch here now. Between the two nodes, element is connected. Between the two nodes, elements are connected only. Finally, how many number of branches are existing in the given diagram? If I ask 1, 2, 3, 4, 5, 6, totally 6 number of the branches are existing in the given network only we can say. That's why how many number of branches are existing? Directly we can write number of branches equal to how many? 1, 2, 3, 4, 5, 6 I said now. 6 branches are existing. Like that branches can be calculated. That means between the any two nodes, whenever an element, electrical element is existing, that will be considered as a one branch only. Like the total number of branches existing in the given network, you identify and try to get it. That the number of branches equal to 6, it is available only. I think the students could understand clearly this point only now. understand. Yes, so far what we said, what I explained, what is the circuit I said, and also I said what is the network I explained, and also I explained what is the node I explained, and next I explained what is the branch, because these are the words we are going to use continuously only now in the network analysis now. Next one, what is required is loop. This is also more important. We are going to use loop. The problem contains how many number of the loops. If I ask means we have to understand only what is the meaning of that loop. Any closed path, any closed path, any closed path is called as loop, is called as loop. Because whenever all these definitions are given, clear concept you will get only, you can say. Any closed path is called as a loop only. You can understand. If I gave one example, easily you can understand only here now. Suppose I connected one resistance this side R1. And I connected one more resistance of R2 this side. And also I connected one source this side. The source is connected this side. And one more resistance R3 I connected this side. Finally, we form the diagram in this way. I ask, can you say how many number of the loops are existing? Anybody can give answer? Any students can give how many number of loops are existing in the given network I am asking. Anybody can give? Anybody can give how many loops are there in the network? Anybody? If any student has got any idea, they can give easily now. How many number of loop means what I said, a closed path is called as a loop only here now. Suppose I selected this side, the path I selected this side. This becomes a first loop. That is going to be a first loop only, I can say. If I selected the what now, any closed path this side, second closed path I selected this side. That can also be said as a second loop only, you can say. That also a loop only now. But students should not say the given network contains only two loops only, sir. It is not acceptable only now. Still one more it is existing. If you selected the what now, path in this direction, if you selected the path in this direction, one more loop is creating only now. If I go this side, I can get only now. But in the closed path means what you can say, starting point and ending point must be same required only now. Starting point and ending point are the same, then we can say it as a what? It is a closed path only, we can say. In the first loop, you watch now first path. This path, whenever I select it, now starting from this point and reaching to the same point only. Here also starting from this point and reaching to the same point. Even here also starting and ending point will be same only now. Then finally, how many number of loops are possible from the given circuits? 3 only. Yes, very good, Vipin. 3 loops are possible here now. So we can say total number of the loops are here possible. Number of loops. Number of loops equal to 3 only possible. So that many number of loops you can form. I think you followed what is the definition of the loop, how to find out the number of loops from the given network only now. Next level, we can go there now. But what is mesh is also very important, because we are going to use, you take the mesh, you take the loop, I am going to say. Then you have to understand what is the mesh and what is the loop also. I wish to explain what is mesh. These are all the just the basics of the what now, network analysis only. If the students followed very well, 100% they can understand the depth of the subject also easily now. Mesh means what you can say, a loop in which we cannot form, any any small loops, any small loops is called mesh, I can say. That is called as a mesh only now. That is called as a mesh only now. The students can understand clearly if I explain with example. In the example, what I wish to take, I wish to select the what now same network which I gave before. I connected like this. Here connected with a source B. And I connected one resistance R1 here. I connected this R2 for example. This I connected with resistance R3. Such a way the connection is made. But I ask the student here now, how many number of meshes, how many number of mesh you can find in the given network? Anybody can say how many mesh are existing in the given network? Anybody can say? Loops means you know. Good evening, sir. Yes, Amit Goyal. Good evening. How many meshes are possible from the given network? Anybody? Loops means I said already 3 loops are possible. Mesh means what I said, a loop in which we cannot form any small loops again. For example, this path I selected for example. This can also be called as a mesh. Mesh 1 I can put here now. That is also a loop. Understand now. And also can be called as a mesh also. Difference is what you can understand. And one more, I selected this path. I can get one more mesh. Mesh 2 I can get here now. In the loop also I have taken, this also a loop only now. And one more third loop I said already, what now? I will select the path in this side. This is one more loops are we said now. But this cannot be taken as a what now? Mesh only now. Mesh, whenever you have taken small loops is not allowed only, I said now. That means whenever you have taken this one, this is taken as a mesh, suppose, mesh should not contain any small loops. Any small loops already, because internally it contains 2 more small loops are existing now. That's why that should not be considered as a what you can say mesh only now. That's why finally how many meshes are existing means only 2 are existing only. So number of mesh can be taken as a 2 only possible. But externally I have taken these paths are, that will be said as a loop only, but not mesh. It is said to be a loop, but not mesh, I can say. This is not a mesh only now. That can become a loop only possible. Like that what you can say, definition of the mesh we can give, and how to find out the number of mesh in the given network can be calculated by this methodology only. I hope students would understand that point only now. Understand now. Next point what I wish to give is, but certain elements we have to, certain points also we need to explain in the basics. Charge, current, voltage, power, energy. These are the terms generally we are going to use where in the network analysis only. If the students is exactly following this definition, means you can get idea what is the current, what is the voltage, what is the power and the energy, everything you will get the clarity only now. If the student is getting the clear clarity, depth of the subject, you can do easily now. I want to define at first what is the charge. Charge is required because any network, in the network element, what a network subject is totally covered with these elements only: charge, current, voltage, power and energy. We can't find more than that only now. Understand now. That's why I want to define what is the charge. Charge means it is the physical property. It is the physical property of matter, physical property of matter. Also they will define, some people will define like this, or it is the physical property of subatomic particle, subatomic particle. Like that also we can define. Sir, I don't understand what is the meaning of this. Clearly you give the concept. Yes, I will give. Clearly I will give regarding this charge. Understand now. The first you have to understand, in the electrical networks, we are going to find the wires. They are nothing but the conducting material we are going to use. Copper, silver, like that, aluminum, these are all used generally only now. And what I wish to say, the matter means what now? The matter is nothing but matter exists in three forms, everybody knows clearly. There may be solid, there may be liquid, otherwise it may be a gaseous state only possible. These are three states we can find. In the network, we need to pay attention on the what now? What matter we want? Solid only we are going to take. But we know very well, any material is formed by the what and what? Formed by the number of atoms only. Without atom, we cannot find any matter only, we can say. That means, but exactly what we can say, matter is what now? Matter is formed by elements and compound. Elements and compound only. Any material or any matter is of two forms. One is an element, one is a compound only. When we can say it is an element, when we can say it is a compound. Suppose any matter or any conductor, clearly you can give that matter is a conductor. Any conductor is formed by similar size of atoms, to think it so. Similar size of atoms onwards, any matter is formed. At the time it is said to be what now? Element only. That is called as an element. Sir, why this is required means you can understand clearly. If the matter is or the conductor is formed here, for example, by the dissimilar size of atoms, big one and small one and big one and small one, like this. Like that is forming only, for example, dissimilar size of atoms. If any material is formed, any matter is formed, we can call it as a what now? Compound only. Compound. So the material, whatever you are using, where in electrical circuits, is with element only. There is an element only. Similar size of atoms only, they will form the what now? Conductors only here now. Now the point what I wish to say, the element is the combination of number of atoms only. And finally, I selected one atom, for example. An atom is a minute particle. An atom is a minute particle. I'll give the clear clarity. It is a minute particle. And suppose in an atom, what you can find, a nucleus is existing. It is surrounded by number of electrons. Existing number of electrons around the nucleus. Suppose there are 2 electrons in the first orbit, I selected here now. To know about the charge, this is very important. So what is this importance means you can understand. Suppose I selected here certain electrons, for example, 3 electrons I selected, for example. Catch my point. To know well about the charge. Any atom contains a nucleus, and also what? and also it contains electrons also. The electrons are not being stationary in their orbit level. They will try to revolve around the nucleus only. Around the nucleus, they are going to revolve only now. But they are going to revolve in different radius only now. Different radius, they are going to revolve only, we can say. The electrons which are existing in the outermost orbit will be helping to flow the current only, you can say. These are said to be valence electrons. The valence electrons only will be helping to flow the current only, we can say. Now, electrons are existing and nucleus is existing. The nucleus is nothing but the what now? It is the combination of protons and neutrons. Why these informations are, you will know. To define the charge, these are all very important now. Directly, I cannot give a simple definition now. This is nothing but the nucleus. This is nothing but the nucleus. Nucleus is the combination of what and what? Protons and neutrons only, everybody knows. Protons and neutrons. Neutrons. The basic, the foundation of network is requirement. These are all very important ones. The protons and neutrons means can you have, but these are each, but the protons, neutrons means it doesn't have any charge. No charge for the neutrons. It doesn't have any charge only. The protons can hold, electrons can hold some charge. They only having the charge. The name of the charge is applicable for the what now? Protons and neutrons only here now. That is why here what I wish to say here now, protons and neutrons, but students will get one doubt, sir, electron is revolving, sir. Why the nucleus will not revolve, sir? Such a question also arising for some students also now. Electrons are revolving, you are saying why nucleus is not revolving. The weight of the nucleus, the weight of the proton is 10,000 times higher than what? Electron only possible. 10,000 times higher than the what now? Electrons only now. Its weight is a very large. There is a immobile, that one. What is immobile? The nucleus is a immobile. The electron is going to revolve only. Anyhow, here then protons and neutrons we can find out. The charge are of two types. One is a positive charge, one is a negative charge is possible. The protons can have the positive charge, and also what now? Electrons can have the what now? Negative charge only. That's why you can say there are two types of charges here now. There are two types of charges. Two types of charges, I can say. Two types of charge. One we are saying as a negative charge. Negative charge. The negative charge is for what? Negative charge for electrons only possible. Negative charge for electrons. For electrons. Electrons possible. And second one, positive charge for what? Positive charge for protons only here possible. Protons. That's why electrons can have the negative charge and protons can have the what now? Positive charge only now. But atom is said to be neutral. When we can say atom is a neutral, atom is said to be neutral. Atom is neutral we can call. When we can say neutral, when negative, but the number of electrons and number of what you can say protons are equal only now. Number of electrons equal to number of protons only. If these two are equal, protons, then we can say atom is electrically neutral, we can say exactly. Electrically neutral. Electrically neutral. Whenever it is electrically neutral, what is the charge had by this particular atom? If I ask, zero only possible. It doesn't have any charge because the sum is having the positive, someone is having the negative. Totally whatever it is cancelled, and finally whatever the net charge is existing. But when the atom is electrically neutral, the net charge equal to how much? If I ask, directly students can say net charge it is existing in this particular atom is nothing but net charge equal to 0 they are going to put on. Net charge is 0 only possible now. Suppose I have taken one atom here now, for example, the atom is existing here now, electrons are there now. Suppose from this atom, I removed certain number of the electrons only now. Certain number of the electrons I removed. Whenever certain number of electrons are removed from this orbit, from this atom, then what dominance you can find? The dominance of the, what you can say, protons is mostly possible only now. Dominance of proton is possible. In that case, net charge is greater than 0 or less than 0 is possible. Anybody can say? Whenever I removed certain number of electrons from the what now, outer orbit of atom, you think it's now. In that case, it becomes the dominance of protons is mostly possible now. Now, anybody can say, in that case, the net charge is greater than 0 or equal to 0 or less than 0. Any student can give answer for this? Any student can give answer for this question. The net charge is greater than 0 or less than 0 or equal to 0. We can say exactly. That means what I said, if electrons are removed from atom, you think it's so. It becomes what we can say, the atom, then dominance of proton is more, we can call. Proton is more only possible. Whenever the dominance of what now proton is more, we can say the net charge is always greater than 0 only possible. That means here in this particular atom, deficiency of electrons possible. Why deficiency? We removed certain number of the electrons from the what now outermost orbit only now. In that case, dominance of what now protons is possible. In that case, net charge we are going to call it as put it as a what now greater than 0 only possible. In case students will get it out, if electrons are added, if electrons are added in an atom, electrons are added in an atom means what dominance we can find? Electrons are added means what dominance is possible? Electrons dominance is mostly possible. That's why if electrons are added in an atom, the dominance of electron is more. Dominance of electrons is more only, we can say. The dominance of electrons is more. In this case, net charge is taken. Net charge is less than 0 only possible. The concentration of electrons in an atom is increasing, you think it's so. At the time, net charge is less than 0 only possible. If the number of electrons from the outermost orbit is removed, you think it's so. Deficiency we are finding of electrons. In that case, we are going to call net charge is greater than 0 only, we can say. Suppose from an atom, whenever you are removing certain number of electrons, you think it's so. At the time, we can call the proton's dominance is a more, it becomes a what now? It becomes a what you can say, immobile charge particle also, it becomes only. Understand my point now? Anyhow, the information is required regarding the charge. Understand? And next one I will define the now. Next one, what is required is, but what are the units of, I have forgotten to give the now, what now? What is the, but the charge units, what units we can give it to the what now? What now? Charge only now. Units of charge. Units of charge is to be taken as a what now? Coulombs only now. Is coulomb. We can put on it now. The charge of electron or the charge of proton in magnitude, if it is taken, how much it is possible? 1.602 into 10 power minus 19 coulombs only, we can say. That's we can write the charge of electron or proton in magnitude. I have taken now proton in magnitude. In magnitude means sign will not be considered here now. In magnitude is 1.602 into 10 power minus 19 coulombs, we can say like that now. That means for a sign also I want, sir. For electrons we can put minus 1.602 into 10 power minus 19 coulombs only. For protons, what I can put, sir, plus 1.602 into 10 power minus 19 coulombs we can put now. Such a way we can put charge of electron or proton in magnitude only. Next one. Next definition which is required is current. Current definition is very important. Next one. How to define the current? Any student can give? Many students know, I think, definition of the current. What way we can define? Anybody? Any student can give the definition of current? Any chance? The flow of electrons in a conductor is called as a current only, definition. The flow of electrons. The flow of electrons in a conductor. But it is a network analysis, that is why in a conductor. In a semiconductor also possible here now. That is a different one story. The flow of electrons in conductor. Conductor is called as current. Is called as current, we can define. This is the definition of the current only. Sir, mathematically you define currents are. Theoretically we define flow of electrons in a conductor is called as a what now? Current only defined. But the students may have a doubt, I want mathematically, sir, or mathematically we can define in this way. Mathematically it is defined as the time rate of charge, time rate of change of charge also we can call otherwise. Rate of change of charge. Rate of change of charge, otherwise time rate of change of charge also we can define only now. Current definition exactly. So how we can write the current? If you want to define means I equal to what I said now, dq by dt, time rate of change of charge, dq by dt. By using this formula only now, current is calculated only now. The current is calculated by this formula only. I equal to dq by dt is accepted. That means exactly what now? Charge by time can also be defined, or you can write that directly. Current equal to charge by time. That way also you can define. It's not a mistake to write. That's the current only now. How that current will flow? In a network or circuit we can take it now. As an example I will give. I connected the what now? Resistors like this. I connected with one battery. Here connected with some voltage. Here connected with a resistances R1 and also connected with a resistance R2 only. How the direction of current will be shown in this circuit? Is it from positive terminal to the negative terminal? The current direction is to be taken from the negative terminal to the positive terminal. You please tell me. This terminal bigger terminal is taken plus, small terminal is to be taken here minus 1. How the direction of the current will be taken? Anybody? How the direction of the current is to be taken? Is it from the positive to negative or negative to the positive only possible? Anybody can give answer? Anybody? So the direction of the current we are going to put in this way only now. Positive to negative will be taken only now. Positive to negative is possible. This is the current I. A name given to this current I is conventional current only. Conventional current, you can put this name. Conventional current it is called. But actually definition of the current you watch, what is given? Flow of electron is a current only. Flow of electrons means electrons will move from positive terminal to the negative terminal, or flow of electrons are possible in the circuit from negative terminal to the positive terminal is very, very important one now. How it is possible means please watch. This is nothing but the wire. This is nothing but the wire. The wire, W-I-R-E, wire I am saying now. That is a conductor. That conductor is formed by the what? No, number of atoms only. Without atoms, there is no material. So this total wire is with number of atoms only, we can say. But atoms means we know again, it contains at the center nucleus. Around the what you can say nucleus, electrons are going to revolve, I said already. The electrons which are existing at the outermost orbit, I said as a valence electrons only. That only can allow to establish the current only here now. So try to catch my point. Suppose this is the material is containing the so many atom. I selected one atom for example. Here electrons are existing here now. Electrons are negative charge. This electrode is a negative only. Electrode is a negative. Valence electrons are existing for example. Negative and negative, what is going to happen? Repulsion. Repulsion force is going to be developed here now. Because of that repulsive force, what is going to happen? The force which is developed here will help electrons to drive in this wire. Electrons are going to move in this direction only now. Because of the repulsive force from this negative electrode, the valence electrons are going to move in this direction only. Electrons are moving this side. And they were all attracted by what? Positive electrode only. The electrons which are existing in the outermost orbit will be repelled by the what? No, negative electrode. Because of that repulsive force, electrons are driven to front and they were all attracted by the positive electrode only, you can say. Then current direction is which side? Means this is the current direction exactly. Electron flow of electron is nothing but a current. The electrons are moving this side only. Electrons are moving this side as per the definition. Flow of electron in a conductor is called as a current. So current is electrons are moving this side only. Sir, when the electrons are moving this side means why you have taken direction of the what now? Current in reverse direction. Doubt is going to arise only now. Why the direction of the current is taken in reverse only now. But suppose the student said, I will take the direction this side, sir. If you selected the direction in this side, sorry, the direction is taken this side, that current is given a minus I and given a name, that is given a name natural current. This is the natural current. This is said to be natural current only. Why is it natural? Because flow of electron this side, that becomes a natural current one. Sir, why you have taken minus there, sir? I don't understand clearly, sir. Okay, I will give you, no problem. I gave already definition, the current equal to charge by time. Charge means you will take Q by T only. What is the charge? How we can measure the charge? Nikhil Gaurav, please don't write below the circuit. Very good, very good. Sorry, sir. No, I will put at the top hereafter. But the charge by time, is it going to flow a single, but a charge is nothing but number of what you can say electrons only here now. Electrons can hold the charge only now. There's a Q can be given one more name, N into E is allowed, N into E by T only. Where N means we can say number of electrons. Number of electrons are going to move. E means everybody knows the charge held by the what now? The charge had by the electron. The charge possessed by the what now? Electron. The charge possessed by the electron, everybody knows, already given. 1.6 into what now? Minus 1.6, that E value, electron charge I gave it. For magnitude I have taken already 1.602 into 10 power minus 19. Magnitude is not considered, means electron means it can have negative, minus 1.602 into 10 power minus 19 is possible here. Now catch my point here now. For example, 100 number of electrons are moving in this wire. 100 number of electrons are moving. N equal to 100 you will put. What is E? E equal to minus 1.602 into 10 power minus 19 you are going to put. T is nothing but the what now? The time for 1 second or for 1 minute or whatever it may be. The time period also you have taken for example. When E is with negative means finally the current you will get with what sign? With a negative sign only you are going to get only now. With a negative sign only mostly it comes now. That means whenever the magnitude of what now charge is positive, magnitude of the charge is taken, you will get directly positive only. Exactly the charge which is had by the what now electron, if it is taken, it comes with a minus, and finally current also will come with a what now negative value only now. As the current is in minus I you got, I wish to convert that into plus only now. Plus is required means what happens now? For our convenient purpose, what is that convenient? Negative value you want to specify as a positive. This conventional direction of the current is taken only now. The conventional direction of the current is nothing but opposite to the what now? Flow of electrons it is taken. But some people will say the current is opposite to the electrons. That's a convenient purpose, a conventional direction we have taken only now. What convenient purpose? Negative value to convert into a positive value, we took the direction in this side only. There is a conventional direction. Finally, every question is done with conventional value only. Suppose I ask any student, can you bring minus 5 kg sugar from the shop? Minus 5 kg means immediately they will watch top and bottom only now. What? Is he a mad? How I can bring the minus 5 kg sugar only now? If I said the 5 kg sugar is required means they can understand. Okay, 5 kg they will go and bring the what now from the shop only now. In the same way here, what I wish to the current you are getting from the what now natural current we are getting with a minus sign. In order to get positive value, we are putting the what now direction in opposite direction only now. Finally, we got an idea I think now how to measure the current from the what now? These definitions only. Current means what I said, flow of electrons, I said the first point. Second one what I said, current can also be calculated with charge by time. Charge equal to Q by T is allowed. Q means N into E, number of electrons flow by T. Understand my point now? That way we can find only, you can say. Next one. This is nothing but the current. The next definition which is required is, but first we can do certain problems also best now, because by using these formulas, I wish to give certain problems only now, simple problems only now. How to apply, you will understand only now. Then after we can enter into the next definition, what is voltage, what is the power, what is the energy, and everything will be given here now. A small problem I want to give in your hand. A current of, this is one of the problem. A current of 0.5 amperes, 0.5 amperes is drawn. This is the foundation of what now? Network and foundation course only now. Here what now? Basics only it is given clearly only now. Every basics will be given now. The problems also from the basics only I am giving now. Understand? Once you have followed the basics means next you can start the what now? Any difficulty topics only now. A current of 0.5 amperes is drawn is drawn by a filament of a filament of an electric bulb, an electric bulb for 10 minutes, for 10 minutes. Minutes, 10 minutes. Find the amount of electric charge. Find amount of electric charge, that flows but how to find out the charge? To know only this I am giving here now. Flows through the circuit, This is one of the simple question anybody can do without my help also. But I want to give time. Please, okay, but anybody can try this question. Please, you try this question to solve. I gave the formulas already, how to measure the current, how to measure the certain points I gave, how to measure the current. By using that current formula, you can calculate this. Anybody can do this and can give answer. What charge is possible? Anybody can find? I want the charge. How we can measure? Anybody? Anybody can do this question without my help. But in this problem, you watch a current of 0.5 amperes, it is given. I am taking the solution here now. The current is given 0.5 amperes. Is drawn by a filament of an electric bulb for 10 minutes. Time is given 10 minutes. But the time must be in seconds only it is required. If it is given in minutes, you convert into what now? Seconds only now. And T can be taken as a 10 minutes it is given. 10 minutes it is given. Minutes you have to convert into seconds only now. 10 into 60 we can take now. 10 into 60. It becomes 600 only. But we know very well current equal to already definition I gave. Current equal to what I gave? Charge by time already given to you. Simple definition only and simple problems only I am doing here now. Charge by time. Here I want the charge. Charge is taken Q. Charge equal to how you can determine current into time. Current into time I can write directly. We know very well what current is passing here now, 0.5 amperes, not milliamperes, it is given amperes only. Time is given as a 600 seconds only you will get here now. This becomes a seconds only now. That's why 600 I can put here now. And finally, its value becomes 300 only now. 0.5 into 600, 300 is possible. What are the units of the charge I gave it already? Coulombs only now. That's why I can put C, coulombs. I can put here now. That way we can determine the charge for the given problem only. This is one of the simple question from the foundation. Understand? Now I will give the next example, one more in your hand. You make an effort to get answer for that question only now. Understand? One more question I will give, you will get the clarity. a conductor has a constant current, a constant current of constant current of 5 amperes. 5 amperes it is given. 5 amperes. How many electrons pass? How many electrons pass a fixed point? Pass a fixed point. How many electrons pass a fixed point on the conductor? In 1 minute. In 1 minute. In 1 minute. This is the question is given. Anybody can solve without my help. Every formula is given in your hand only. Easily you can do this question. It is not going to make the students to feel any difficulty. In an easy way, I am giving the what now? Each and every one of the example now. In an easy way, every definition I am explaining you now. If the students are perfectly catching the what now subject means, they will improve to a lot only now. Understand my point now. Anyhow, please try this question without my help. I will give you some time to try to get answer for this. What is asking in the problem? What is given? You check it. Then you can do easily. Yes, I will do the solution here now. You'll get idea. A conductor has a constant current of 5 amperes, it is given. How much current is passing in the network? I equal to, we can put directly 5 amperes only. The current which is passing in the conductor is a 5 amperes, even clearly. How many electrons pass a fixed point? How many electrons only? How many number of electrons are passing because of this current now? Number of electrons I want. N equal to how much? Number of electrons passing a fixed point only on the conductor. In 1 minute is given. Time t is given 1 minute. Already I said the time must be in seconds only allowed, I said now. Minutes to convert into the second only. 1 into 60, I can write directly. It becomes a 60 seconds. I am getting that much time period only now. But in the problem, we are in need of n value. How we can measure? Everybody knows very well, already given. Charge equal to what I gave it already. The charge Q, the charge is given a name Q, is nothing but N into E, I said already. The charge equal to N into E, already given only now. The charge equal to N into U only now. And here I am in need of what now? Current equal to, everybody knows. Current equal to what? NE by charge by time T. NE by T only now. I am in need of N. N equal to, I can write current into time by E value only. By using this, you can measure easily even now. Current is given in the problem. How much it is given? 5 amperes only. I can put directly 5 amperes. The time is given. How much? 60 seconds it is given. I can put directly 60. Divide by E. The charge of electron we know in magnitude only we have to consider now, magnitude only now. I will take the what now minus or E value, no, that time N value becomes a negative value now. That is why in magnitude E required 1.6 into 10 power 1.602 into 10 power minus 19, everybody knows 1.602 or 1.6 into 10 power minus 19 also accepted. Then you will get N value approximately equal to, it comes as 1.875 into 10 power 21 it comes mostly. 10 power 21 is mostly possible. We cannot give any units for this. Number of electrons. So, how many number of electrons are passing because of the flow of this current? If anybody asks directly, you can say 1.875 into 10 power 21. That many number of electrons are passing in the given network only, we can say only now. That way we can tackle this question only now. These are all by using the numerical values only now. Sometimes he will give graphically also. Graphical diagrams will be given in your hand. By using that graphical diagram, you need to find out the charge also. But in the next session, tomorrow also you try to attend the class from 4 to 5:30. There I will give by using the what now graphical figures if it is given, what way we can find out the Q value. Sometimes it comes a necessity by applying the integration also, what way we can calculate. Every point I will explain in the next class. Don't miss and try to attend the class. Okay, we can close the what now this session. Tomorrow, try to attend, don't miss it.